Okay, hello, we are the team named MetaVersPloit. We would like to talk about the vulnerability analysis of a broken commercial Metaverse virtual office platform. So, everyone, it's great to have all of you here. It's great that you are actually having me. It's my first time in Berlin, and I really appreciate this invite. Okay, let me shortly introduce our team. We formed the team within the BOB program operated by the Korea Information Technology Research Institute. Our team is passionate and at the forefront of solving security challenges that align with new technology directions. Burn the midnight oil with people who share the same interest as a security perspective for the upcoming metaverse environment. Well, today we are going to explain 13 common features of a commercial platform composed of various metaverse virtual office environments. This part is used to find the vectors that can occur by using common functions when analyzing vulnerabilities. Afterward, we will look at the vulnerabilities that occurred in each platform in line with the vulnerability analysis methodology. You work in a metaverse environment, not in the real world. As tech work increases worldwide, I often work at home while using Zoom and Google Meet platform. However, as their values and sense of reality are lacking, various platforms that allow work in virtual environment, there is the metaverse space, continue to increase. Unlike security flaws in real-world companies, virtual office security flaws in the virtual world can inflict additional damage. Yes, we have been conducting this study to reduce the security threats that are invading amid the rapid growth of the metaverse platform. Now, in the vulnerability analysis to find the target of the metaverse virtual office, the community is active. And statistically, it was selected based on the most used by users. Among them, GatherTown, Office, Kumo Space, and Spatial platform were selected and analyzed. As a result, each platform was analyzed using the vulnerability analysis methodology studied within the team, and a total of 31 vulnerabilities were found beyond expectation. Great. Now let's talk about the vulnerability analysis for each platform. First of all, let's take a look at our vulnerability methodology. We established a vulnerability analysis to analyze the vulnerabilities of the target application. The following are 13 common features for each metaverse virtual office platform. We will give a brief explanation by looking at the following table. Among the first selected metaverse virtual office platform specific features, this is a list of 13 common features through research by the team. In detail, the space inside the virtual office is called space. And the feature of enter, exit a space, enter, exit a room, inviting space, and the like. Among the calculated common features, we have organized them in the form of a checklist for each platform. In the previous slide, we did a technology stack analysis to form an architecture with 13 common features. For each platform, important technologies used in the multi-application environment are classified, and they are commonly classified into front-end, back-end, and IPC categories, which are core technology stack parts. The red bold font matches 13 common features and technology stacks, and we conducted vulnerability analysis on the technology part with high weight. Now, our team member Young-Eun Kim will announce the vulnerability of the Gather and the Spatial.
Hello, I'm a researcher, Young-Eun Kim.
Wait, please. Okay.
Okay. Hello, I'm a researcher, Young-Eun Kim. Unfortunately, I was not able to participate offline because I was infected with the coronavirus. Therefore, we ask for your understanding of the presentation we can conduct it online. Great. Now let's talk about Metaverse virtual office GatherTown platform with vulnerability analysis. The GatherTown platform can check the architecture as shown in the below figure. I want you to know that in the below chart, the order of the highest breakdowns of service uses the core. Let's see among them attack vector checkpoint. First point, analysis of vulnerability led to avatar, maps, and themas in WebSocket octet vectors. Second point, Electron.js framework vulnerability analysis in binary environment. Third point, analysis of communication led to vulnerabilities in web artist octet vectors. Fourth point, web application vulnerability analysis. Fifth point, third-party vulnerability analysis. We found a total of 6 vulnerabilities in the GetOutTown platform. Among them, I will talk about 2 vulnerabilities with critical severity. Great. Now let's talk about remote code execution and privilege escalation as critical vulnerabilities that we found. Among the common features mentioned above, RCE vulnerabilities were found in Space, Loom, and Object-M plugin. The following is the root cause for the remote code execution vulnerability. Yes, it is a binary for the GetOutTown platform. This is the main.js code after unpacking the electron.js-based app.acl file. You can control the browser window property on initial loading of the binary. In this code, you can control its detailed property through the web response property. Let's take the current set properties. In the first period property, interrupt.js code implemented by internal development will be imported. This code contains an externally executable script, which is an important factor in triggering the vulnerability. The second context isolation property is disabled. This part is used because it preloads an external script. If you look at the picture, you can see the features implemented in the GetOutTown platform. Using the MainMaker service, you can create space and various objects that users can use. Among them is the concept of tiles. Among the various effects, one of the vulnerable factors is the portal tile. Portal tiles can be moved from one space to another in GetOutTown. This is a structure that redirects to the other GetOutTown domain in the web application concept. You can use these features to connect to other GetOutTown domain implemented externally. If so, a vulnerability will occur in the part that said if. It is GetOutTown platform in MainMaker service. The following code is part of the logic that receives and processes the domain address from the client side when setting up portal tiles in MainMaker service. It is judged whether the string localhost gather.town is included among the host names of the URL input by the user. After that, after inserting into the filtered object, client processing is completed. With this concept, if you insert a URL as an input value using the allowed localhost string as follows, you can bypass the filtering condition and insert the desired URL to have an external service access direction. Now that we have a portal that we can move it in any direction, we need to create a portal interaction condition in our binary application. However, when we tested this web application, we could see that it moved to another external service through this portal, but an exception occurs in the binary. To find the exception, we analyze the code implemented in the binary. Now let's check the vulnerable part in the code. Interestingly enough, I found the regular expression check for filtering like this. If you analyze the regular expression simply, you can see that the domain must be GetOutTown unconditionally in the case of STPS schema, and the string is received as a subdomain. It does that this condition could not be used. I thought that the second regular expression condition could be used as long as it includes localhost when using the STP schema, but a slightly additional part was needed. Condition can be satisfied when localhost contains clone character. This pattern can be found in RFC 3986 protocol. Since it is used in the form of user clone password URL, the following payload can be implemented using this condition. After ignoring localhost clone anything, redirection to the exploit domain becomes possible. We have followed the process for loading external script early. Now, I will explain the process for executing Electron.js remote code execution by executing an external script. I explained the root cause, do you remember? Yes, this property is enabled to process with the preloading interrupt.js code. If you check the interrupt.js code, you can see the following method name getCurrentWindow. The function can have information about the window object instanced from the browser window object. If so, you can use this function to get a change to set up new window. Because we have a ton of the same origin place property, we can communication with other origins. You can escape the current window isolation because you turn off the context isolation property. Finally, we enable node integration among the properties web response that arbitrary, so we can perform remote code execution using the Node.js module. Okay, here is the payload video. So attacker users and click the man maker service. User is input the URL. After inserting the URL of the web server contains the payload into the normal portal, users install the portal in a lot of space. And confirm to the save. When other users interact with the portal, the payload is executed and remote code execution is performed and successfully. Okay, next vulnerability. Among the common features mentioned above, privilege escalation were found in Spatial. In order to proceed with the explanation of the root cause of the vulnerability, the user invitation service of the GatherTown platform will be divided into normal flow and abnormal flow. This flow chart shows normal service. Users with member privilege send invitation emails to invite other users. The GatherTown invite manager of the server issues invitation tokens for integrity and authentication and emails them to target users. The user who receives the invitation link connects to the target room with the invitation token and is registered as an owner members of the room. The following exploits the vulnerability to trigger privilege escalation. The attacker creates a fake room with the admin member privileges and created an invite link. At this time, GatherTown invited manager of the server issues a token based on user data. The attacker uses the issued invitation token to attempt unauthorized access to the attacking room. At this time, access the room while acquiring admin according to the authorized issued. Finally, the privilege escalation is performed successfully. Okay, let's look at the next picture. The whole scenario is visually constructed. The binary attacker target is to take over the host through remote code execution in the Metaverse virtual PC space. First, to gain access to the target space, the attacker creates a token value by opening a baked space with sophisticated privileges. After that, prepare an attempt to access the target space and change the permission by manipulating using baked token with more than the owner permission. Change the permission in the order of admin and builder with the target space. Finally, an attacker with sophisticated privileges install the manmaker functions prioritized in a location-free country used by normal users. Of course, this is the state with the remote code execution payload. A user who steps on the install prioritized get remote code execution like falling into a black hole, and the attacker takes over the host. Yeah, this is the end of the GatherTown platform description. Okay, next I'll talk about the vulnerability of the Metaverse virtual spatial platform. This is spatial platform architecture. Before I talk about vulnerabilities, I will briefly introduce the spatial architecture. Spatial platform architecture uses the Unity engine to load balance photon cloud and transmit and receive voice using live switch token. In addition, authentication information is transmitted using proxy of reactive. We found the vulnerability of fitting in Spatial. I'll talk about vulnerability that I think about the three most critical things. The first and second vulnerabilities led us to one vulnerability. Among the common features mentioned above, the generate live switch token API were found in access control. The API issues token used to access the voice server. When requesting a token, send the room ID of the voice server to be connected. Then it issues a JWT token used to access the server. However, the API is inspection to verify on the server, so attacker can send the desired target room ID. Safely, only tokens per accessible room should be able to be generated, but that's not the case. Then attacker can be issued JWT token that can access the target voice server. Looking at the image on the left, data is manipulated and sent using the bubbleshoot proxy. The image on the right, you can see that JWT token was issued as a response value. Okay, next vulnerability. Among the common features mentioned above, the vulnerability of screen sharing that led us to API vulnerabilities were found in access control and chatting. When the screen is shared, it is shared to all other users connected through the live switch server. If attacker manipulates the generated live switch token API to access the target's live switch server, attacker can see the screen that's shared by others. It does not verify that it is an accessible user on the live switch server. So if you have a token, anyone can access it. Okay, next vulnerability. Among the common features mentioned above, the vulnerability of approaching the potent voice server and eavesdropping another room. They are found in access control and share. The server channel is room ID plus low-line voice low-line queue string. Use this to connect to the server. If an user access the channel, on player entered room function is called, your user information is registered and speaker object is created through the create speaker function for conversation with the other people. Verify that the room ID plus low-line voice low-line to string and the voice channel ID are the same in both the functions. Through this, it is verified that voice channels are not allowed in other rooms, but this is verification is client side. So with those, the code is C#, so it is possible to manipulate and recompile use DNSpy open source tool the code. We manipulate the code to access other room. First, before connecting to the server, we manipulate with the target room ID. Second, the return value of the IC connected to collect room function was unconditionally set to true. I tell you again through the picture. There is a victim's room above and attacker's room below. Attacker is in his room, but the voice channel is manipulated to access the voice channel of the victim's room. And if the user accesses the victim's room, the on-played entered room function is called and new user information is registered. Then create a speaker object that can listen to new users. Therefore, attacker can listen to the user's voice in the victim's room. I played a demo. This demo is a screen sharing picking up and a voice eavesdropping. The small screen on the upper right is the victim's room and is meeting. And the big screen is the attacker rooms. The attacker treats voice eavesdropping and shares the screen from his room. Let's see. Okay, we implemented the attacker scenario that exploiting the vulnerabilities found. First, I talk about authentication bypass and information collection step. It is possible to bypass authentication and collect information using the three vulnerabilities we found. It is possible to identify excited email information through the exploring excited account vulnerability. It induces the installation of a malicious application capable of tapjack and task jacking through DNS spoofing and transmits sensitive information from users. Second, I talk about the target search step. Attacker can collect the room ID using vulnerability sorting. Vulnerability sorting is that if room ID is pressed in the URI path and requests the information of the users in the room and the room ID owned by the user can be obtained. Basically, you should be able to request only for room that you can access, but it is not verified by the API. So user information about accessible rooms can also be obtained. Collect and select the ID of the target room. Configure the payload using the selected target ID. Finally, you can take advantage of the previously introduced vulnerabilities to pick up screen sharing or eavesdrop on voices in the target room. This concludes the description of a Spatial platform vulnerability. Next researcher, Young Kim, will explain the vulnerabilities of the Office platform.
Yes, I will run now. Okay. Okay, next I'll talk about the vulnerability of the Office. Each Office architecture, Office uses an external URL to open video, Office and website functions in iframe and uses a WebSocket server for maps, themes, avatars, moves, and locations. This chapter is the architecture and OT configuration of the Office platform. WebSockets, WebRTCs, objects, and applications that conduct IPC communication were selected as attack vectors and vulnerabilities were identified. A total of 5 vulnerabilities were identified, and 4 of these vulnerabilities were found to be critical. First, I'll talk about the privilege escalation from guest to visitor. The following is the process of entering the private space. First, request the knock function to enter the room. Second, get permission to enter the office or conference room through an internal URL API call. At this time, when entering the office, you can get visitor permission, and when entering the conference room, you can get the guest permission. The following are vulnerabilities that can take guest authority at arbitrary private workspace. The root cause of the vulnerability is due to the lack of verification of the inclusion relationship between the office and the conference room. When calling the API, it modifies the attack target room value, room ID, into the attack target room ID and requests it. If it is tampered with, you can get the guest privileges when entering the conference room. The following is a vulnerability that can unlock or lock the meeting room. The root cause of the vulnerability is due to the lack of verification of the API caller's permission. When calling the API, it modifies the attack target room value, room ID, into the attack target room ID and requests it. If tampered with, you can unlock or lock the meeting room. The following are vulnerabilities that privilege escalation guest to visitor. The root cause of the vulnerability is due to the lack of verification of the API caller's permission. When calling the API, the target office value workspace ID is modulated with the target workspace ID to request. If it is tampered with, you can get visitor privileges. At this time, the visitor doesn't need a knock process. Second, I'll talk about the iframe plugin XSS vulnerability. The following is an analysis of the vulnerability function that XSS can cause. Plugin, object user, and interactive content features are as follows. When plugins and objects are installed within the space, the surrounding area is created. You can use the content using the iframe function around the created area. The following is the vulnerability configuration. Attacker can install an iframe object with an attack payload inserted and derive an iframe XSS via inline JavaScript. At this time, when an attack payload is inserted and a normal user interacts with the iframe object, the payload is executed and XSS is generated. The following is an analysis of XSS vulnerabilities. iframe.js source code shows insufficient filtering in the source attribute input vector. The following is the video with inline JavaScript and error. The video is where I'll play later. The reason this script is executed is that frame ancestor is set to none and script source and object source are not set. Third, I'll talk about the picket static object XSS vulnerability. The following is an analysis of the vulnerability function where XSS can occur in the picket among static objects. Plugin, object user, and interactive content features are as follows. When plugins and objects are installed within the space, the surrounding area is created. You can use the content using the iframe function around the created area. The query editor source code modification feature allows attackers to install a picket object with an attack payload and induce XSS. At this time, when an attack payload is inserted and a normal user interacts with the picket object, the payload is executed and XSS occurs. The following is an analysis of XSS vulnerability in a picket object. You can modify the HTML source code by enabling the code edit option in the query editor. When you insert a script into the image tag, the part of query editor that modifies the code, you can see that the script has been executed as follows. The reason why the script is executed like this is that frame ancestor is set to none and script source and object source are not set. This is POC video to elevate privileged guest to admin. First, insert XSS script in iframe plugin. And then session hijacking allows you to gain API token and elevate privileges to admin. when code is executed. In here, the guest member is changed to this, and this is admin in Korea. This is admin in Korea. So next, the obvious attack scenario is shown in the following figure. First, you get guest permission in space. If the room in the space is private, unlock the lock and gain guest privileges. Second, elevate the privilege from guest to visitor. Finally, insert the XSS payload into the iframe, picket object to elevate admin privileges. Next, execute the session hijacking script when the victim interacts with the infected object. Finally, the attacker uses the stolen token to raise the authority to admin. Now, I'll talk about the vulnerability of CommSpace platform. This is architecture and not a vector configuration of the CommSpace platform. WebSockets, WebRTCs, object, and applications that perform IPC communication were selected as attack vectors, and vulnerabilities were identified. This is architecture of CommSpace. It uses WebSockets to send avatar, movement, chat information, and communicate map and SIM settings information. WebRTC communication uses Agora server to transmit voice and Twilio server to transmit video and display. A total of 5 vulnerabilities were identified. Among them, we will introduce the socket manipulation vulnerability that we consider to be serious. Now, I'll talk about the chat sniffing and information leak using unauthorized space connection. This is normal WebSocket communication in CommSpace. When you send a JW token with the identity comment, the server checks it and checks the user's permission. Then you will receive information about the config comment and room. This is a normal WebSocket communication from an attacker. When sending a chat message using the previously used API, if you change the space name to the target space, you can send the message to space without JWT token authentication. This is an attack screenshot using Python POC code. You can send a chat to all rooms, or you can send a one-on-one direct message. At this time, the sender's ID is unknown, so the sender sends a message anonymously. So this is video, shows the chat sniffing and information leak. In this video, victim is in room named Meta Room. So you can see in console. Here is now sent to Meta Room. And if the victim chat hi, and and hi, attacker can see message that victim's chat message, and attacker can send message anonymously, like hi. So next, the CommSpace attack scenario is shown in the following figure. Send the newly created space name and select the target space through space name duplicate verification. Connect to target space and hijack chat session between users in space to eavesdrop on chat. Okay, now I read the presentation with the summary of the vulnerability impact. Let's take a look at the table categorized based on the attack effect we have compiled. This was not my part, so if this is not smooth, please understand. For each attack effect, we have shown assets, platform, and application, and we have inserted resources that may be affected. Representative properties include screen and voice, user guest information, chatting log, custom object, document, etc. The application field includes both binary and web or one of the both. Now I will look at the possible ripple effect scenarios for each attack effect and explain the countermeasures. The front of each page is a scenario development diagram and the right is an assets that can be affected by the platform. The first is the eavesdropping. The eavesdropping can be done by voice, chat, or video, and in the case of Spatial, there was a scenario of forced unmute. By forcibly releasing the mute, privacy impingement of specific team or corporate members may occur. In order to protect this, increased communication, client-server verification, ID verification, and cross-access verification are required. This is those scenario. In the case of virtual office, if availability is compromised, it can be said to be fatal because it affects actual operations. In the case of Spatial, there is an application-level DOS scenario. Abnormal service operations cause financial and time losses while reducing corporate reliability. Add IP and MAC controls to use resources or limit available resource per hour to prevent those. Next is information disclosure. Virtual Office have sensitive information from users, so you should be careful to steal information from attackers. In addition, I was able to steal sensitive information such as users' GPS and email. The ripple effect is as follows. There is a concern that proposal information such as IP and GPS will be exposed. Set up an authentication system so that only authenticated users can access it. You will not be able to deliver other users' information, or you will need to encrypt them. Next is phishing. Phishing impersonating a virtual office is easy to internal users to be deceived. In addition, there is a risk that information inside the office will be stolen. In GatherTown, we were able to send emails to users using official emails. The ripple effect is as follows. Redirection to the attacker's malicious site is possible through email phishing. Only authenticated users should be able to accept it, and malicious site sharing should be prevented by limiting the URL link type. Next is unauthorized user penetration. Office was able to attempt unauthorized access after the administrator's authority was elevated. The ripple effect is as follows. Unauthorized users can access and backdoor attacks into corporate space. Strictly manage the login process and set the session retention time within 1 to 2 hours. Next is a manipulation of the document. In GatherTown, object manipulation and creation were possible, and the ripple effect was as follows. RCE and integrity damages are possible through object modulation and creation. Divide the authority to perform document deletion, modification, addition functions. It should be applied so that all users can serve it with one authority. Next is the function detour. I was able to detour the functions offered for a fee on the Spatial platform. The impact is as follows. By bypassing the full function, you can use $240 per year and $25 per month without the pro team purchase procedure. In terms of target space, financial damage is possible. Hard-coded logic should not be applied. Authentication must be performed in a challenge response method on the server and client side. The paid function is only available when the authentication result is true. So far, we've looked at the vulnerability assets and possible attack scenarios of a Metaverse-based virtual office platform. The COVID has accelerated non-face-to-face operations, and many people have actually used virtual office. Meta, the leader of Metaverse, has a virtual office platform called Horizon Workroom, utilizing Oculus. Although it wasn't in the announcement, you can use the motion to import and export your work. And you can actually implement the future work environment you imagined. We predict that these virtual office platforms will grow and become more and more as the number of users increases, and the risk of stored assets will allow increase. I hope we can all think about the security threats that may arise in this process in the future. Thank you for listening to our presentation. Thank you.